Hello, everyone. Um, Through this demo, I'm trying to explore what happens when zero trust meets AI agents. As AI systems become increasingly autonomous in nature, with agents calling other agents, making decisions, and moving data, security becomes a critical question. Who authorized that agent interaction and can we trust one agent? And most importantly, what happens when one agent is compromised? It's a interlink of agentic communication that is happening within the environment, right? So I built a live answer to all these questions on using the framework of NIST SP 800-207. Um, and that's the framework that we are going to be using for this particular demo. And so for agents, I build them in Azure instance, and it will show you demonstrate a real fraud detection pipeline. And there is a deliberate breach attempt and how to recover. Before I show the demo, let me set the scene of what use case I'm trying to achieve here. Imagine a bank. Every second, thousands of transactions are flowing through credit card transfers, payments. Traditionally, a rules engine flags suspicious fraud activities. We are replacing that with AI agents that reasons about transactions the way fraud analysts would do. So here is a pipeline, right? A very high level pipeline of it. A customer swipes their card, transaction hits the agent one, and that's called as the intake agent. It's the agent that enriches any sort of raw transaction data by using the Azure OpenAI. So that this transactions can be anywhere from a grocery purchase to a international wire transfer at 3 a.m., right? So once after that, agent one passes that enriched data to agent two, that which is a risk scoring agent. It generates a risk score from say 0 to 100 using AI reasoning. If it is a low score, it means that the transaction is regular, it's normal actions. And if the risk score is high, it means that there is some suspicious activity and need to escalate. And if the score is high, the agent three, which is the alert agent, is basically invoked and it drops a human readable alert for the fraud team, right? And this fraud team could be sitting somewhere out, which is a human-based team, right? Every single action is recorded by agent four, which is a compliance logger in this case. And all these logs are being collected within the Azure Log Analytics platform also. So four major agents, these are the four agentic avatars, and each have a very specific job, a very specific operation, and specific permissions also being given. None of them, most importantly, none of them don't trust with each other by default. And this is very important because in a traditional system, once you're inside the network, you are trusted. If an asset or an identity is inside the network, you are automatically trusted. Whereas, so agent three could call agent one, agent two could read the audit log. So we are going to throw that model completely away. And this is where I want you to introduce you to the zero trust framework. And every call between agents are authenticated in this case. Every permission is explicit and every actions are logged. So I'm going to show you all these three different scenarios of normal operation, a breach simulation, and a recovery as well. right? So let's go to our Azure portal here. And I have all the four agents ready to go. It is live. It is live in production, and it is being built in the Azure Container Apps. So these are the four agents I was talking about. The agent one, which is the intake transactions agent. Agent one receives all the transactions data and it enriches that data using the Open AI Azure. And agent two is a risk agent. And this is basically used to score the fraud risk. Agent 3 alert agent is a evaluates as well as drafts the alerts and send it to the fraud team. And the agent 4 is a compliance logger. So every single communication between these agents goes through one place, which is the APIM. And I'm using the API management service from Resource in the Azure instance. And this is the API is the consider this as the policy enforcement point. In zero trust architecture, there is this concept called as policy enforcement point, which is which is the policy enforcement engine that decides which policy each of these containers should be receiving. So all the global policies are managed through this and enforced through this APIM. And it makes sure that the agents never communicate directly with each other. Every agentic call is intercepted, and every agentic call is authenticated and authorized. So you can add all these policies through, the API processing workflow. So it was quite sleek in that nature in terms of adding the policies through through each of these APIs. So the global policies managed through the APIM, and this is the policy enforcement point in this scenario. Now, consider a scenario in which I have the URL um, for accessing the one of the agent. And if say this is the URL and I'm opening up in a browser and trying to access, so right away it is throwing the 401 error message. And this is the core of zero trust. It doesn't matter that I am inside the Azure network. It doesn't matter that I know the URL. No valid identity, meaning no access to the agent as well. So this is one important concept that Zero Trust is providing. So this is applied to all the other three agents as well. So all the four agents are having this particular policy being applied at the same time. So now if I switch real quick into this terminal, and we are going to show a regular transaction, right? So this is where a customer is making a transaction, like a purchase transaction or a regular grocery transaction. And in this case, let's see. So if you see here, this is a whole food transaction, $85.50. And if you look at these three green lines, the tenant two, which is the principal number two, were all the connections and the communications that the agent one. By the way, if you were paying attention, the agent one is the transaction um, agent, and agent one is handling that any sort of transaction process. So all the communications are secured and HTTPS with the JOT token, and all these communication requires this jaw token as well. So no plain text, no shortcuts, and Agent one fetches the um, short-lived identity token from the Entra ID, and this is required. This is a one-time badge or like a one-time token, and this is used for the agentic calls. If you see here, the APIM validates that JAW token before it's letting anything through. So this is where the policy enforcement act upon and look at that particular token if agent one can act is legit to communicate with the agent two. Because if you think about it, the natural workflow of this, when a transaction comes through, that transaction is being processed and from the raw transaction data, and that processed enriched data is being sent to the agent two, which is the score agent, and it will provide the score. And so this is where what I'm showing here is the communication that is happening between agent one to two, right? And if you see here the 500 error, it's a configuration issue which I need to fix in production. But the most important thing here is that the zero trust controls, which we have configured here, is key to notice, and it's very important that agent one adhere to that policies as well. Now, once after that, let's see if we can simulate a breach scenario. And in this scenario, what we are going to do is that an agent three, assume that an agent three has compromised. Agent three is an alert agent and it has compromised. An attacker is inside the container. Their goal is simple, that reach the agent one and steal the transaction data, right? So that's the attempt this agent three is going to do after it got compromised. So in a traditional system, they are already inside the network. They might succeed. Uh, let's see what zero trust does. So I'm executing that breach simulation scenario in here. And so a breach simulation active, it is detected. Agent 3 has been compromised. It will attempt to access raw transaction data from the agent 1, ensuring the agent 3 is redeployed with agent 3 compromised. So let's see what happens in here. So this is a suspicious transaction of 4,850. And so this the score of this particular transaction is high, and agent 3 will be invoked because, as I said earlier, agent 2 invokes agent 3 whenever there is a high risk. And agent 3 invoked by agent 2 via APIM, of course, that is the policy enforcement point. Agent 3 is attempted to call the agent 1 in this case. Agent 3 is a compromised agent in this scenario, and it is trying to reach out to or call the agent 1, which is an unauthorized call, basically. The agent 3 is a compromised agent, and it is attempting to reach out to agent 1 to steal the transactional data. And here in this case, the APIM is returning a 403 error and say their scope validation got blocked. So APIM checked agent 3's token in this case and confirmed it has zero permission to call the agent 1 and blocked it in the real time. And this attempt is logged into the agent 4, and Azure Log Analytics have that log record as well. So if you think about it, in this case, the agent 1, 2, 4, all of these agents are fully operational and they are unaffected and they are continuing to do the operation that they are allocated to do or targeted to do. Whereas the agent 3 is a compromised agent. And first of all, the system detected it as an unauthorized call, agent to agent call. And it got isolated or quarantined, and it now cannot access the data at all. It has no scope for accessing the data from agent one. And now the only way in an enterprise scenario, the way I'm seeing this as in this situation, the agent three can be completely quarantined. And once the quarantine is supervised by a human in the loop, and once that investigation is complete, you can unquarantine it after you revoke the certificates, after you revoke the secrets and keys of that agent three, right? And so this is exactly what here it is also mentioning, that revoke the agent three's token in the Entra ID and certificate and secrets, delete the client secret. And this is what is going to be done in the recovery stage. So if I go back here, and if I go to the Entra ID, and if I go to the app registrations, and agent alert, this is the agent number three, and this is the agent alert. And I can see the certificates and secret, and delete the client secret. This is the recommendation through this is following the zero trust principle as well. So the certificate and the secrets need to be revoked at this point, and it is simple as revoking like this. So um, agent three's token is now invalid across the entire system, right? So any subsequent call that the agent three is trying to make anywhere, you will receive a 401 error. As I said, I didn't touch at this point agent one, two, and four. They are just continuing to do their own operations. All these audit logs are being set into the agent for the complete record as well. The one thing that I can also show is the GitHub repository that has been prepared for this. So this is the full scale of what we have done so far. And in order to see uh, the deployment, build and deployment, there is the full structure of all the codes that has been going in here. And so no passwords are being stored here anywhere. And it's been the GitHub authenticates to the Azure using the federated credentials. And yeah, this is the build and deploy. And the last thing that I want to show is the sort of a high level mapping of what we have achieved here. The first one being all the data sources are treated as resources. This is one of the first tenet or principle in the zero trust. So in this case, we have used the Azure OpenAI, the Key Vault, and the APM, which is used for establishing this particular policy. All the communication is secured through HTTPS and the JOT token. Per session access, and that's it through the short-lived Entra ID session tokens. So there is no standing permissions, and access by policies implemented through the API policy engine. Monitoring all the assets. In this case, the asset is the agents. So all these agents are being monitored, logged within the Azure Monitor. And dynamic authentication is via using Entra ID validates every token in the real-time basis for whenever there is a session initiation is happening. And last but not least, the continuous improvement through the GitHub Actions build and deploy cycle. So this is a full demonstration of the zero trust architecture principle. As AI agents become more and more autonomous in nature, this is the security model they need. NIST 800-207 wasn't written really for AI agents, but it turns out to be exactly a right framework for them. Thank you so much for listening.